Good morning students, how are you? Hope you all are safe at your home. എല്ലാവർക്കും സുഖമല്ലേ? Okay, today we are going to discuss about a new chapter, chemical kinetics. Before we entering into the chemical kinetics, let's revise something about the thermodynamics and equilibrium. In plus one, we learned about the thermodynamics and equilibrium. Thermodynamics is a branch of chemistry which deals with the feasibility, the energy changes. Feasibility means the spontaneity. You know that delta G is negative, the reaction is spontaneous. And delta G is positive, the reaction is non-spontaneous. And if delta G is 0, the reaction is at equilibrium. In the chapter equilibrium, we discussed about the extent of reaction. That means how extent the reaction takes place, how far the reaction occurs. At the same time, another important factor, the speed of the reaction. If the speed of the reaction increases, the reaction completed very fastly. So, chemical kinetics is a branch of chemistry which deals with the rate of the reaction and their mechanisms. As you know, the mechanism is the step in which the reaction follows, the path in which the reaction follows. We studied in organic chemistry. So, the term kinetics is derived from the Greek word kinesis, which means movement. So in this chapter, we are discussing about the speed of the reaction or rate of the reaction. How we calculate the speed of a vehicle, that means the speed of a car or a bus. The distance covered by the vehicle per unit time. We say that 60 km per hour, 40 km per hour. So we have to express the concentration, we have to express the rate of the reaction in terms of change in the concentration per unit time. So rate is the change in the concentration of any one of the reactants or products. Once again, the rate of a reaction is change in the concentration of any one of the reactant or products. So before we entering into the chapter, so the key points in this chapter, we have to discuss so many points in this chapter. The points are, one is rate of the chemical reaction, second one is factors affecting the rate of the chemical reaction, third one is rate expression, fourth one is order and molecularity. Fifth one is integrated rate equation. Sixth one is temperature dependence of a rate of a reaction. The seventh point is effect of catalysts. And the last is collision theory. So these points we have to discuss in the chemical kinetics. Are you okay? Manasalayo? Okay, then we move to rate of the reaction. We know that different types of reactions. The type of reaction means very fast reaction, very slow reactions, and moderate or average speed of reaction. The reactions can be classified into three types, mainly three types. One is very fast reaction. For example, in laboratory, we detecting the presence of chloride ion by adding silver nitrate solution. When you add a silver nitrate solution into chloride containing solution, the chloride taken in the test tube, the AgCl, a white precipitate is deposited or formed in the test tube, that is AgCl. At the moment of mixing the two solutions, the precipitate is formed. That means the reaction is completed. So that comes under the very fast reactions. All ionic reactions are fast reaction or instantaneous reaction. എല്ലാ റിയാക്ഷൻസും ഇൻസ്റ്റന്റേനിയസ് നമുക്ക് പറയാൻ പറ്റും. Ionic reactions are very fastly completed. So ionic reactions are very fastly completed reaction or instantaneous reaction. The second one is very slow reactions. In electrochemistry, the last topic is corrosion. The corrosion of metal. For example, rusting of iron in the presence of moisture and air, or air and moisture. The iron oxidizes into ferric oxide, and X number of water vapors, water molecule is absorbed on the surface. So that is the rust Fe2O3xH2. This reaction takes place very slowly in the atmosphere. It takes weeks, maybe months, maybe years. So this reaction is very slow reactions. You collect more example about the very slow reaction, that is generally corrosion of metals. A green verdigris is deposited on the surface of the copper. Tarnishing of silver. Silver ornaments in the surface blackening. That is a slow reaction. Then the third one is moderate speed or average speed reactions. For example, digestion of food. The digestion of food requires 3 to 4 hours. The hydrolysis of starch. When we take starch, it takes place within 2 to 3 hours. So digestion of food, the hydrolysis of starch, ester hydrolysis. One of the example is ethyl acetate, an ester present in the fruit, which is hydrolyzed in the presence of water, and the medium is acidic. So ethyl acetate hydrolyzed gives acetic acid and ethanol. So this is a reaction which occur in the moderate speed or average speed. So the classification is clear. I think it is clear to you. Reactions are 3 types: very fast reactions, very slow reactions, and moderate or average speed reactions. The rate of very fast reaction and a very slow reaction determination is difficult. So you know that the reaction is completed at the moment, at that instant, so the change in the concentration calculation is difficult. So the rate or speed of the very fast reaction and the very slow reactions are difficult. In this chapter, we are discussing about the rate of the reactions, which comes under the moderate speed or average speed. Very clear? Yes. Then we move to the rate of the reactions. As already I told you, the rate of the reactions, the rate of the reaction is change in the concentration of any one of the reactants or products. നമ്മൾ ബസ്സിന്റെ സ്പീഡ് കണ്ടുപിടിക്കുന്നത്, കാറിന്റെ സ്പീഡൊക്കെ കണ്ടുപിടിക്കുന്നത് ഡിസ്റ്റൻസ് ട്രാവൽഡ് ബൈ ദ കാർ. ഒരു കാർ എത്ര സമയം എത്ര ഡിസ്റ്റൻസ് കവർ ചെയ്യും എന്ന് പറയുകയാണ്. ഞാൻ പറഞ്ഞു കഴിഞ്ഞു 60 km/h. That means the vehicle covers 60 km in 1 hour. Similarly, we have to express the rate of the reaction in change in the concentration. The concentration can be calculated by moles per liter. In plus 1 we discuss, also in plus 2 we discuss concentration types: molality, mass percentage, volume percentage, etc. So we are using moles per liter, that is molality. So change in the concentration is determined in a regular interval, and the change in the concentration or any one of the reactants or products per unit time is the rate of the reactions. Then unit of rate of the reaction. rate is equal to change in the concentration of any one of the reactants or products per unit time. So what is the unit? That concentration is expressed in moles per liter and time is expressed in seconds. So what is the unit? Moles, liter inverse, second inverse. This is the unit of rate of the reaction. Remember that the unit of reaction is moles, liter inverse, second inverse, because rate is equal to change in the concentration of any one of the reactants or products per unit time. Are you clear? Yes. Let's consider a reaction. Consider the hypothetical reaction. Reactant gives products. In this case, we generalize the reactant gives products. And if R1 and R2 are the concentration of reactants at a time T1 and T2. Two different time T1 and T2. The concentration of the reactant is R1 and R2. Similarly, the concentration of products at different time is P1 and P2. So P1 and P2 are the concentration of product and a product at a time T1 and T2. Sorry, just a mistake. T1 and T2. So what is the change in the concentration of reactants? A change in the concentration is final concentration minus initial concentration. So change in the concentration of reactants delta R. In +1 we discussed about delta U, delta E, delta G, etc. What is delta G? Delta G is G2 minus G1. What is delta H? Delta H is equal to H2 minus H1. So similarly, delta R is equal to R2 minus R1. That is the final concentration minus initial concentration. Similarly, the change in the concentration of products, delta P is equal to P2 minus P1. That is final concentration of product minus initial concentration of products. Similarly, we have to express the time change. The change in the time delta T is equal to T2 minus T1. Are you clear? Once again, consider reaction. R gives P. R1 and R2 are the concentration of reactants at different time T1 and T2. P1 and P2 are the concentration of products at T1 and T2. Change in the concentration is R2 minus R1. Change in the concentration of product is equal to P2 minus P1. Change in the concentration of, change in the time is equal to delta T, T2 minus T1. So what is the rate of the reaction? As we know that the change of a reactant means initially the concentration of reactant is high. On passage of time, the concentration of reactant is decreases. Very clear? Initially, the concentration of the reactant in the reaction is higher. On the passage of time or സമയം പോകുന്തോറും reactants-ന്റെ amount കുറഞ്ഞു വരുന്നു. So initially the concentration of the reactant is higher, then it is decreases. So decrease in the concentration of reactant divided by time taken. So rate of the reaction can be expressed in rate is equal to minus delta R divided by delta T is equal to delta R is also written as earlier, delta R is equal to R2 minus R1. So you have to substitute into equation R2 minus R1 divided by T2 minus T1. The minus sign indicates, you know that R2 is smaller. In the case of reactant, the final concentration of reactant is smaller and the initial concentration is higher. So the difference should be negative. So the rate become negative if we don't put the minus sign in the equation. So we multiply with the minus 1 to get the rate of the reaction is positive. R2 ആണ് വലുത് എന്നല്ല, R2 ആണ് ചെറുത്. R2 concentration of reactants ആണ് smaller value. അപ്പൊ സ്മോളർ വാല്യൂ നിന്ന് ഹയർ വാല്യൂ സബ്ട്രാക്ട് ചെയ്ത് കഴിഞ്ഞാൽ നമുക്ക് കിട്ടുന്ന നെഗറ്റീവ് വാല്യൂ ആയിരിക്കും. അപ്പൊ റേറ്റ് എന്തായി പോകും? റേറ്റ് നെഗറ്റീവ് ആയി പോകും. In order to avoid that, അത് മാറ്റാൻ വേണ്ടിയിട്ടാണ് നമ്മളൊരു -1 വെച്ച് മൾട്ടിപ്ലൈ ചെയ്യുന്നത്. അപ്പൊ നെഗറ്റീവ് ഇൻറ്റു നെഗറ്റീവ് പോസിറ്റീവ്, the rate becomes positive. Are you clear? Yes. Next, similarly, the rate of the reaction can be also expressed in the change in the concentration of the product. So, the rate of the reaction is equal to increase in the concentration of product. Initially, the concentration of product is 0, as we know that. Then, what happens on the passage of time? The concentration of product increases. Reactant becomes decreases, product become increases. So, increase in the concentration of products divided by time taken. Let's substitute the previous equation into the rate. The previous equation delta P is equal to P2 minus P1. Then we substitute here delta P divided by dt is the rate. So P2 minus P1 divided by T2 minus T1. Here we know that the final concentration of the product is higher than the initial concentration of product. So these are different. The subtraction of P1 from the P2 is positive, so the rate should be positive. So here you remember that the negative sign is to represent the decrease in the concentration. Otherwise you will get the rate is negative. So decrease in the concentration is represented by minus delta R. You should remember these points.